Okay, let's review these concepts again and do the shorter notation, which I'm sure you're going to like because it's less writing. So this line has arrows at each end. So this line goes on and on forever in both directions. So if you're thinking of it in terms of left and right, it goes on forever and ever in the left direction and forever and ever in the right direction. So your domain is, you can just write XER. X is an element of the real numbers. Now, if you're thinking in terms of up and down, this line goes up forever and ever and down forever and ever. So every single real number along the y-axis exists in the list of all the points that are on this line. So range equals y is an element of the real numbers. Now that was explained. What a real number means as opposed to whole numbers was explained in the last video, and that was done pretty well, so I'm going to leave that there. Now this guy, he doesn't have an arrow here. What am I doing? He has just that last dot there, and he has an arrow here. So this line goes on and on forever towards the right and towards up, but it does not go on and on forever towards left. It stops there. And it does not go on and on forever down. It stops there. So domain equals x is an element of the real numbers, which means it's not just 1, 2, and 3. It's every number and decimal in between the whole numbers, such that x is going to go like this. So it's going to be 0, 1, 2, 3, 4, and on and on and on. So such that x is greater than or equal to 0. If this was an open circle and not filled in, wasn't an actual point on 0, then you would take away the equal to. But this was an actual point here. It's filled in on that spot. So it's greater than or equal to 0. And the range is y is an element of the real numbers such that y is. Now y starts here at 2 and goes up and up forever and ever. So y is greater than or equal to 2. So we're really getting into details here. For this line, let's pretend that, can I change the color? Yes, I can. Come on. Oh, there. Okay, let's pretend there's an open circle here. Can I move him? I don't think so. Let's make that better. Open circle. Close enough. Right there. And this is a closed circle. So, let's write open circle so we know what we mean. Open circle, closed. Circle. I don't know if you guys can see in the video, but I keep pulling that ruler down. Okay, so x is our domain. Domain is x is an element of the real numbers because it's not dots, it's a solid line, such that x, I'm going to erase that because x actually goes between here and here. This is solid, this is an open circle. So x is between 1 and 2, 3, 4, 5, 6. Now, because this is a solid circle, that's going to be an equal to. This is an open circle, so that's just less than, not equal to. And the range is y is an element of the real numbers such that, now what is y in between? 2 and 3, 4, 5. So y is between 2 and 5 for the range. So y is between 2 and 5. It is not equal to the 2, but it is equal to the 5. Okay, let's take a look at the next one. I'm going to erase this so we have more room. Okay, so now we're doing this line, and our x exists from there to there. Our y exists from there to there. So domain equals squiggly bracket x, e, r. X is an element of the real numbers such that x is between, and they're solid points. There's no open circles. So equal to, x is between and equal to 1, 2, 3, 4, 5, and 6. And squiggly. Range is y is an element of the real numbers such that y is between and equal to 0 and 1, 2, 3, 4, 5, 6. 0 and 6. Okay, in the next video I'll do the parabolas because they seem to have disappeared.